Phi carries the identity of G to the identity of G bar. Let's write that down. Claim. If Phi is an isomorphism from G to G bar, Phi of E must be E bar, where E is the identity in G and E bar is the identity in G bar. Why would that be true? What would you need to do to prove that? Let's do a little scratch work here. You'd want to show that if I got any element G bar in capital G bar, must show that if you multiply phi of E times G bar, you get that G bar, because that's what it means to be the identity in G bar. So the question is, how do you do that? At least one way it could be done, maybe this is not the most ideal, but it certainly is a possibility, is you could say, well, since phi is onto, that means there exists a G in G, capital G, such that phi of G equals G bar. Maybe I should use that fact. That means if I multiply phi of E and G bar, I could write it as phi of E times phi of G. And then I could use the fact that phi is operation preserving. You got to use that fact somehow to write this in this way. And then E times G is G. And then by definition, this equals G bar. It looks like I've done it. But it's actually going to turn out later in this class, after spring break, in fact, that you actually don't need to use the fact that such a mapping is onto to make to prove it maps E to E bar. There's going to be a generalization of the idea of an isomorphism to what's called a homomorphism, where this kind of thing will still be true and the function won't necessarily be onto. So this must not be, this does prove it, but it must not be the only proof. And I think the book doesn't prove it this way. I think what they do is they play around thinking about things like this. This just takes some experimentation sometimes. First of all, E equals E times E. And phi is OP, operation preserving here. Maybe I should write this as phi of E times phi of E. And this thing, that's an element of G bar here. That could be written as E bar times that element. And now, right cancel. That implies E bar equals phi of E. That's the way the textbook does it, essentially. But once again, you've got to keep your wits about you. You've got to realize what's going on here. That's the hardest part. The plane E is an element of the domain G. The E bar, that's the identity in G. E bar is the identity in G bar, the codomain. You got to look at equations like this and not be confused. That's an element of G bar, the identity in G bar, times an element of G bar. Since that's the identity, this product equals that. E, being the identity of G, does equal E times E. And phi is operation preserving, so I can expand that like this. So I've got the equality of this with this. I'm trying to show phi of E equals E bar. Yeah, now do the right cancellation. But it's tricky. You got to think about it. You got to practice these kinds of things.